Okay, so this is number 8 on your review. It says there are about 6 million humans on Earth in the year 2000. If human beings double their population every 50 years, what will be the human population in the year 2500? And then it gives us a hint about figuring out how many times it's going to happen, because you have to think about how many 50-year periods there are in this time frame. So we could figure out or put all the zeros in for 6 billion humans, but I'm just going to leave the word billion there and remember to myself that I'm not talking about starting with 6 humans, I'm talking about starting with 6 billion. So that's going to be our starting amount. Our rate is that they double. So our rate is 2, or 200%. And then our x, remember x is how many times it happens. So if it happens every 50 years for 500 years, then it's going to happen 10 times. And you could figure that out mathematically by dividing. 500 divided by 50 equals 10. So it's going to happen 10 times. So that's the number I'm going to put here. So I'm going to have 6,144 billion humans. And then if we want to write that correctly, we would be writing, I believe that's the right number of zeros. So this many humans would be our final answer. Okay, if you'll flip to the next problem, which is number 14. It seems a little blurry to me. There we go. A bacteria doubles every 7 hours. Keep in mind the word doubles is going to be our rate. The biologist has 48 bacteria now. 48 now means that's our starting amount. How many will there be in 42 hours? And so when we get into the time, we need to take both of these into account. So our starting amount is 48. Our rate is doubles, which means we put a 2 in there. And then it's going to happen every 7 hours for 42 hours, which means we can figure out how many times it happens by dividing. So if it happens every 7 hours and we wait 42 hours, it's going to happen 6 times. So that is my exponent here. So I can just type this in. And I get 3072 bacteria. Then part B says, when will there be 1,200 bacteria remaining? So this is a different question because it's asking us when, which means we don't know the x value. We don't know how many times it needs to happen. What we do know is that we're still starting with 48. We're still doubling it. And then we don't know how many times it's going to happen. We do know we want the total, though, the y, to equal 1,200. So this is a situation where, since we're looking for the time, or how many times it's going to happen, we need to use our graph and type our equations in and see where they intersect. So my graph screen was already set from the problem before, but here's our bacteria growing, and then here is our 1,200 bacteria. So this time right there is going to be my x. So I can find that by pushing second trace, go to intersect, enter, enter, enter. So when the total is 1,200 bacteria, 4.64 time periods have gone by. They want us to round to 3 decimal places. So that's going to be 4.64. That 3 is going to round up because it has an 8 next to it. So 644 times. And we know that each time it happens, it took 7 hours. So to figure out how many hours it's going to take, I need to multiply that times 7. There's 7 hours for each of these times it happens. So 4.644 times 7 would be 32 0.508 hours. So that's how long it's going to take to happen. When? And it would be after 32.508 hours, or after 4.644 time periods. Okay. The last question is number 15. Label the following as linear, quadratic, exponential growth, or exponential decay. So anything that looks like a parabola, that's a quadratic. Anything that looks like a curve and it flattens out and makes an asymptote, that's exponential. And since that's going down, this is exponential decay. And then there's lots of other ways to look at the tables. I'm going to show you one way right now, which is to type it into stat. If you're doing this along with me, you might want to pause the video if I go too fast for you. Once you type it into stat, we want to see what that looks like on a graph. So I'm going to go to second stat plot, which is the y equals key. And I'm going to turn my stat plots on by pushing enter, enter. Then I'm going to go to my window and make sure my window goes from 0 to 3 for the x-axis. Actually, I'm going to put it at 4 just to make sure. I'll do -1 to 4, just so we have a little extra space on the edges. And then my y-axis is going to go, let's go -1 to nope, let's go +1. -19 is the lowest, sorry. And the highest, let's go +1. Because we got to go low to high. So -19, +1, just to have a little extra space. Whoops, and I did something wrong. Oh, I did these backwards. -1 to 4. There we go. So set your window like this, push pause if you need to, and hit graph. And then we can see this shape. This is half of a parabola. So this is quadratic. The other way to tell that it's quadratic is to look at the pattern. If the pattern is going by the same amount every time, like look at this one, it's going down by 20.2 every time. That's a constant rate of change, so that's linear. And if you type this in and turn on your stat plots, you would see a straight line. So this one's linear. This one, the change is different every time. So this is going down by 2, this is going down by 6, this is going down by 10. But if we look at the second change, if we do it a second time, the second change is the same every time. It's going by 4, this is going by 4. So this also tells me it's quadratic, if the second change is the same. Okay. So this one you can do the same way by putting it in stat and turning on your stat plots, I should say. Or you can look at the change. So the first change, let me go back to green. This is going down by 250, going down by 125, going down by 75, going down by 25. So it's not linear because it's not a constant rate of change. Then if I look at the second change, if it's the same the second time, it'll be quadratic. So this is going down by 125, going down by 75, going down by 50. So this is not the same either. So this tells me it's not quadratic, which means the only thing left is it has to be exponential. And since these numbers are getting smaller as the x numbers get bigger, then this would be exponential decay. And you would want to double check that because now I just noticed that these are not going by ones. So we actually might want to put this in stat and check it. I'll do that real quick because now I could be wrong. So So since they're not going by the same increments on x, we can't do this trick. We need to look and see what it's going to be. So I'm going to change my window to go from -1 on the x to 55. And on the y, I'm going to change it to go from 0 to 550, let's say. And so, whoops, I gotta go into y equals and delete this line that I have in here. We don't want those. And so here's my curve. And yes, it does look like exponential decay, so I was right. But be careful. Make sure these are going by ones if you're going to do this trick. Otherwise, you can see it on the graph screen if you turn on your stat plots. So this is exponential decay. The shape graph is very similar to this. You can see that where the asymptote would be right here. It approaches 0, but it never actually hits y equals 0. All right, so that is your review for your test on Monday.